Hey guys, and welcome to the third lesson in our Introduction to Pandas Crash Course. In the previous lesson, we learned about the basic commands to import and run Pandas library into a notebook file. We also learned about the Pandas data structure objects such as DataFrame and series. So now we are ready to cover a more advanced topic to learn about how we can get data into and from Pandas library. So let us quickly click on our lesson number 3. One of the key features that make Pandas such a popular data science tool is the ability to import and export a wide range of data formats. In this diagram, we notice on the left side there are many different types of data formats such as CSV files, Excel sheet, SQL tables, and even HTML data. Each data format has a specific built-in reader function that can convert the data source into a DataFrame object. Examples of these reader functions include read CSV, read table, and read Excel. Each one of these reader functions has a set of parameters that are designed to handle specific data formats. Once we upload the dataset into a DataFrame object, we can start a process and analyze the dataset using a variety of built-in tools and functions. After we finish processing the data, you will have the option to export the Pandas DataFrame into different data formats using a set of writer functions, such as to CSV, to Excel, and to SQL. To find a list of all built-in reader and writer functions, click the Pandas Input-Output Tool link, which takes you to the relevant Pandas documentation page. So how about we start to write and run some code to learn about some of the most commonly used methods to get data into and from Pandas DataFrame. We will start with how to make Pandas DataFrame from Python native data structures. As you guys know, the Python language has a variety of built-in data structures such as lists and dictionaries. These are widely used by Python developers to store data during coding and program execution. However, these tools cannot be effectively used to perform analytical tasks such as exploratory analysis or even data visualization. Luckily, the Pandas library can transfer Python data structure into DataFrame and series objects to allow users to easily perform data manipulation and analysis. So let's have a look at some examples. We will create a typical Python dictionary to save country information. We create a dictionary with 5 key values pairs. The dictionary keys represent the labels or titles in the Pandas object, while the dictionary values represent the corresponding information of the data. So imagine if we have a large number of dictionaries, each one has information about a different country. The Pandas library can transfer this list of similar dictionaries into a DataFrame object. So let's have a look at this example. We create a variable called list of countries as a Python list where each item is a Python dictionary with information about a different country. We then pass this variable as input to the Pandas DataFrame function, which converts the list into a DataFrame object called countries. Also notice how we pass the list of countries codes as the index parameter of the DataFrame object. This is actually an optional parameter, so if we skip this one, the library will automatically create a numerical index value. Finally, we use the head function to display the top rows of our DataFrame. To have more information about these functions, click the DataFrame and head functions link in our notebook file to go to the official documentation page. Another approach to transfer a Python dictionary into a DataFrame object is to use Pandas FromDictionary built-in function. The dictionary key values represent column names, while the dictionary values are Python lists. Let's have a look at this example. First, we create a dictionary. We then convert the dictionary into a DataFrame using FromDictionary function. So for these examples, we see how the Pandas library gave us multiple options to convert Python native data structures into DataFrame objects. We now move to learn about another method to get data from external data source into Pandas data objects. Tabular data is one of the most commonly used data formats. It's basically presenting the data in the form of tables with rows and columns. So we will learn about how to get data into a Pandas data frame from popular tabular formats such as CSV files, Excel sheets, and SQL tables. We start with importing a CSV file that is shared online on 538 GitHub repo. You can get the dataset exact path by clicking the CSV link in your notebook file, and you can also check other available datasets by clicking the GitHub repo link. The dataset we are reading is about alcohol consumption around the world. So we try to create a DataFrame object and we apply the Pandas read CSV function. We pass the dataset path as input parameter to this function. We then display the top records of this data frame using the head function. So we notice here we actually imported the dataset from the cloud, so it's stored online in a GitHub repo, and we pass the dataset file location to Pandas read CSV function. This function can have many other parameters, such as changing the column name, data type, handling missing values, and many more. To have a look at all possible parameters, you can click the function link, which will take you to the function documentation page. Similar to CSV files, we can also import data from Excel sheet files using Pandas read Excel function. In this example, we will use an Excel file that is already stored in our local machine. In my computer here, I save the file in the dataset subfolder as you can see here. So we will create a DataFrame object and pass the file location to the read Excel function. The read Excel function also has a lot of possible parameters that the user can use, such as getting the data from a specific sheet name. You can learn more about these parameters by clicking the Read Excel link, which will take you to the documentation page. Next, we will learn how to import data from a relational database table. To do that, we usually need to establish a connection with a relational database engine, such as Oracle and SQL Server, and then we use SQL language to extract specific data. Pandas library provides the read SQL function to pass SQL query syntax and load the result into a DataFrame object. To simulate this scenario, we will use the Python library SQLite to create a local database file, and then we query the data from this database using the read SQL function. The following code block is not actually part of any Pandas command, but we just try to create an external database source with some data stored in it. We first need to import the SQL engine library. It's called SQLite 3. Then we try to make a path where we store the database file. So we will save it in our local subfolder datasets, and we call it a local database example. Then we need to create a connection between our session and the engine file. We start to establish our connection by adding some toy data into a database file. And finally, we save our changes by using the commit command, close the connection, and run the cell. So we don't have any error, which means the code was done successfully. And basically, we created an external database file with a table inside that file called myTable. And we inserted 3 different records inside that database. We can see this file if we go to our dataset subfolder, and we notice here our local database example file. So now we move to the next step to actually query and extract some data from the external data file and load it into a DataFrame object. So again, we need to run a list of commands and start by identifying the name and the location of our external database. And we need to start a connection with the database file. And we will create a data frame called people, which we will use to load our query result using the read SQL function. Finally, we print our data frame object and close the connection with the database engine. So we see here that we successfully queried the data from the external database file and reloaded it into a data frame object called people. Another common practice for data professionals and Python developers is to access data from third-party APIs. This approach is useful when the data source is continuously updated, such as weather forecast or the stock market price. API response data usually comes in JSON format, which is a common data format used to exchange data between web applications and servers. In this example, we will use an API called OpenNotify to get information about the International Space Station ISS. The API can give us continuous updates about the ISS current locations and crew members on board. To access this data, we will need to run a few commands to establish the connection between our notebook file and the API before uploading the data into a DataFrame object. So first we need to import a special library called requests to help us establish a connection. And we also need to import another library called Pretty Printing to help us to easily read the JSON format. Then we start the connection using the get function and store the response in a response variable. Then we need to convert that response into a JSON format. So let's actually have a look inside this response data to see how it looks like. So we notice now that the response data is basically a dictionary of several key values pairs. And the dictionary tells us there are currently 10 crew members on board the International Space Station. So it's kinda busy up there. This people section gives us a list of dictionaries about the names of all peoples on board. We notice 3 of them are members of the Shenzhou 13, which is, to my understanding, is a Chinese spacecraft that is currently doing a mission with the ISS. This list of dictionaries is very similar to what we learned before about how to convert a list of dictionaries into a Pandas data frame. So let's try to do that in this example by creating a data frame called astronauts to store this list of people. Notice how we pass the exact people section of the response data. And this will give us a nice Pandas data frame object. Finally, we learned about another method to extract data from web pages. Very often, data professionals need to access external datasets from web pages to add to their analytical projects. For example, let's say you are working on a project and you need a dataset about the population numbers of each country. So you do your research and find this table in a Wikipedia page that has information about each country population and the percentage of change. And you need to quickly get this data as a Pandas DataFrame to start working on it. To do that, you usually need to apply something called web data scraping using specific Python libraries like Beautiful Soup and Selenium. However, the Pandas library provides something similar that allows you to quickly do web scraping. So the read.html is a Pandas built-in function that allows you to extract HTML tables from web pages. In this example, we will learn about how we can do that and extract that specific table from Wikipedia page. So the function will take the page URL as a parameter and save the output in a variable called web data. So we notice that the web data variable is actually a Python list, and if we want to look inside that item in the list, we see it's actually a mix of HTML code. The function read.html actually searches for any HTML tag that think it could be a data table. So in order to find the correct table we need, the data analyst must examine the items inside the list and find what are they actually represent. We already did this examination and noticed the very first item in the list actually contained the HTML table we need. So we will access the web data item 0 and assign it into a variable called web countries table variable. Okay, so you see here the read.html function successfully extracted this table from the Wikipedia page. Just note here there are some extra character that is already embedded inside this table. So you see here the brackets and parentheses in the table title, and we see the plus and the percentage signs. These extra characters should not actually be part of this data frame. And later in this course, we will learn how to clean the data frame in order to prepare the data for further analysis. So the read.html function can give us a very quick way to do data scraping instead of using external Python libraries to extract HTML tables. So far in this lesson, we learned about some very popular and most commonly used methods to upload data into Pandas DataFrame. We started with using native Python data structures to learn how to convert lists and dictionaries into DataFrame objects. And then we moved to import tabular data formats such as external CSVs and database tables. Then we learned how to access data from a third-party APIs using JSON format. And finally, we ended with doing data scraping. So all these different options represent the most common ways for the data professionals or Python developers would use to access or upload data into Pandas data object. To learn more about Pandas, stay tuned.